This is day 53 of my 6-mark challenge for AQA GCSE Science. In the run-up to the GCSE exams, I'm posting a new 6-mark question each Monday, Wednesday and Friday to allow you to practice answering these extended response questions. You can find a link in the description below to each week's questions and also access all of the videos which are listed together in a playlist. Before you start answering today's 6-mark question, it's important that you remember that these extended response questions are not essay questions. It's not like English where you're being marked for your use of paragraphs or even spelling and grammar. You need to be laying out your answer in a logical order, but that doesn't mean full sentences. You're allowed and even encouraged to answer in the form of bullet points, numbered lists or tables, and doing this is going to help you to lay out your work in a way that makes it really easy for the markers to mark it. It's really important that you make sure you're answering all aspects of the question. So here we're told that we need to refer to both structure and bonding, but lots of students are not going to do that. They're just going to talk about one or the other, or they're going to do those two, but they're not then going to link it to the fact that at room temperature, oxygen is a gas and silicon dioxide is a solid. So really, I would be answering this in the form of a table with 6 parts. If you haven't done so already, pause the video and give yourself 6 minutes to answer this 6-mark question. This style of 6-mark question is one of my absolute favourites, and it's examined year after year after year in both GCSE and A-level chemistry, for the very simple reason that students are still not very good at answering it, and that's for 2 main reasons. One is the topic. In this question, we're thinking about structure and bonding and how that relates to properties, and I would say this is one of the topics where students are most overconfident, they think they understand it, and really they just don't know the right language to use. And then the second reason is the structure of this. So in this question, we're asked about structure and bonding and why oxygen is a gas and silicon dioxide is a solid, so the states. So we've got basically 6 different things to talk about, and a lot of students don't talk about all 6. So I would immediately be encouraging you to lay out your answer in the form of a table, because that's going to make sure that you actually are discussing both substances and structure and bonding and state. Very often when this style of question comes up, we're contrasting ionic bonding with either metallic bonding or covalent bonding. But in this example, we're actually thinking about covalent bonding for both substances. The difference is that where silicon dioxide is a giant covalent structure, or you might refer to it as a macromolecule, oxygen is a small covalent molecule, or you might refer to that as a simple covalent molecule. Next up, we can think about the number of particles involved. So in silicon dioxide, it's a giant structure, and therefore there are thousands of silicon and oxygen atoms within this giant covalent structure, whereas each oxygen molecule only contains 2 atoms. We've already named the type of bonding in these 2 structures, but we can go on to give a little bit more detail than this. So firstly, we can say that within the giant structure, silicon dioxide, each silicon atom is making 4 single covalent bonds. Whereas in contrast to that, in an oxygen molecule, those 2 atoms are sharing 2 pairs of electrons to make a double covalent bond. But also, as well as those covalent bonds inside the molecule, we've also got weak intermolecular forces, and these are going to be crucial for answering the latter part of the question. So now we're going to start thinking about these states. Why is silicon dioxide a solid and oxygen a gas? So silicon dioxide has got thousands of strong covalent bonds that have to be broken in order for it to melt, and that takes a lot of energy. So it's got a very, very high melting point. And at room temperature, there is insufficient energy to melt it, so it's a solid. Now, oxygen, of course, also has strong covalent bonds, but they don't need to break in order for it to change state. So instead, it's these weak intermolecular forces which take very little energy to overcome. And therefore, its boiling point is lower than room temperature, and at room temperature, it's already boiled and become a gas. On Friday, we're returning to Physics Paper 1 with another extended calculation, this time from the electricity topic. Remember, you can find a link in the description below to all of the questions for this week's videos, and there's also a playlist of all of the videos so that you can find them neatly together in one place. Thank you very much for watching, and I hope to see you again on Friday for day 54 of our 6-mark challenge. If you found this video useful, then don't forget to like and subscribe for more GCSE Science revision videos coming soon.